Everybody is ready for our class. We are going to do some question on electricity. And this is the set that are already given to you earlier. If you have done it, that's good. All right. The question paper. Right. Then we would, do we need to wait for a short while? Do we need to wait for a short while? Maybe 1 minute from now. All right. All right. Without wasting more time, we're going to look at this particular question. All right. Okay. You'll be able to let's do fast. Okay, now these are the questions that I don't want to waste time in our normal class. We want to do it here. All right, take a good look at question number 1. Okay, check the sound. Is the sound okay? Respond, please. Okay, all right. If there is no problem, I will go ahead. What can be observed when we call it high voltage? Okay, electrical high terminal supply is switched on. Okay, based on what you learned in your syllabus, you learn that the how should I say, the flame will be flattened. Agree? All right. So the best word or the best answer you're gonna give for this particular question is none other than it will spread. Okay, C. Okay, right? Is that correct? So if easy question, I will run fast unless it is hard. All right. We know charge will be in coulomb. Remember that? Okay. It is charge will be in coulomb, and then we move to the next one. All right, how many coulomb is that in 1 ampere hour? So coulomb, remember the formula is going to be IT, and this formula comes from current, remember? Right, current equivalent to Q over T. So when I cross multiply, you're going to get IT, agree? So you're given current is 1 ampere, and the time understood, you're going to change it from 1 hour. You notice 1 ampere hour? 1 ampere hour, you're going to change it to a 60. You're going to change it to a 60 minute. All right, you're going to change it to a 60 minute, hang on, and a 60 second. Okay? All right, you're going to change it to 60 minute and then 60 seconds. So you know that it's going to be a, right, 1 ampere times 60 times 60. You know this is what you're going to get and will be in unit coulomb. Do you agree? All right, if you agree, then we won't waste time. Then we move to the next one. Right, what time? Then this is going to use back the same formula. All right, they want to find the time, right? Then you're going to take the time as a subject. It will be a Q over I. I and T will change place. Do you agree? All right, but be careful of the milliampere, huh? All right, okay, coulomb is 2, okay? All right, quantity of coulomb is 2. So this is going to be a milliampere. We're going to change it to ampere. All right, 2 times 10 power negative 3. So understood, you're going to convert and bring this one up to get you a 10 power 3, all right, second, because the 2 and the 2 will cancel off. Everybody agree? All right. Now, the reason I want to do this, I want to make sure that you are good in this chapter, right? Because I'm going to have another, at least 3 more sets, okay, 3 more sets. So this question understood, okay? They'll ask for potential difference. These are the basic question. All right, okay, V equivalent to IR, nothing to explain to you. All right, you'll probably see the number, that's all. All right, 3 ampere times 9 ohm, they will give you a 27. All right, and we know, okay, relationship between resistance and length of the wire, understood. The longer the wire, the higher the resistance. So it's going to be a direct proportional. Agree? Down key, and we're going to move to number 7. All right, they ask you to compare the current. All right, but before we start with current, we compare with resistance. Remember, I always say that in parallel circuit, resistance is the lowest. So in this particular circuit, we know that RQ will be the lowest. Do you agree? All right, will be the smallest. All right, and when you arrange in a series, this is a series arrangement, and just the opposite of parallel. All right, if parallel, the resistance is the lowest. All right, then the series, the resistance will be the highest. So I'm going to put this one at the very right side. It's the highest. So it's going to be, I'm going to put a RP here. All right, so understood. Okay, the one in the middle will be, okay, the one in the middle is going to be, one is R, one is P. This is actually R. So I'm going to put a R here. All right, okay, they are actually using a small letter. All right, okay, they're using small letter. So if they're using small letter, I probably use small letter. All right, okay, I use a small letter. This is a Q, this is a R, this is a P. All right, so I'm going to write again. All right, this is Q, then it's going to be resistant for circuit Q. All right, this is a P, then it's a resistant for circuit P. All right, okay, and this is going to be in the middle. That is going to be, I guess, is a R. All right, R, this one. Okay, this is the one. Boleh? All right. Okay, but resistance and current is always opposite. Do you remember? All right. Okay. So we know that the highest resistance is going to be RP. So the current will be the minimum. Okay, IP will be minimum. All right. And since RQ is minimum, then your IQ become maximum, is terbalik. All right. Then I'm going to put the symbol O terbalik. Everybody agree? All right. So many of you got do this, but I am not very happy with the scoring. All right. The scoring isn't very good. So this is your answer there. Can you compare with what I am giving you with what I have written? All right. Okay. This is a selection for C. Boleh? All right, then we're going to look at this. What will happen to the voltmeter BU1 and BU2 when the resistance of a rheostat increase? This is the rheostat. All right. So when we increase, understood. All right. When this value of the R increase, right, then your value for V2 will also increase, because you know, all right, V equivalent to IR. All right. It will normally will follow the R. All right, if I were to increase the resistance of rheostat, all right, this is rheostat. How do I know? Because you got an arrow there. All right, you got an arrow. So when the resistance increases, then understood, it will make you having a bigger, okay, BU2. So your BU2 must be to increase. All right, to increase. So understood, BU2 increase, then BU1 will be, then what do you think? And when one go up, then the other one go down. This one must go down. All right, this BU1 must go down. Okay, I'm going to explain to you why it go down, huh? All right, okay, because you know that, right, BU2 and BU1, when I add up, it will give you BU-S. All right, I don't forget that BU-S will be the source. All right, the source of the voltage supply. All right, and BU-S is always constant. Clear? All right, BU-S is always constant. So when your BU2 go up, then BU1 must come down. All right, because this is going to be always constant. So in other words, if you were to supply through, let's say 6 volt here, then it will be 6 volt. Okay, 6 volt. All right, it will be 6 volt. So in other words, if you got problem, then I'm going to give you maybe a number to do it. All right, but number is always wasting a lot of time. All right, okay, I'm going to give you a number if you think that you need to have number. All right, huh? Let's say I'm going to give you a number. All right, okay, let's say I'm going to put you 1 ohm. All right, this is going to be a 1 ohm. Right, and this is going to be a 2 ohm. All right, huh? Okay, so we will do the normal calculation. All right, we do the normal calculation. All right, okay, so total resistance is going to be 1 ohm plus 2 ohm. that will give you a 3 ohm. Betul? All right, and then we're going to put current. All right, current is going to be Bu over R. All right, which is going to be a 6 over 3, then become 2 ampere. All right, so I'm going to calculate Bu2. All right, I'm going to calculate Bu2 now. Okay, so I'm going to calculate Bu2. So it's going to be Bu2 equivalent to IR. Right, my I is 2 and my R is also 2. So I'm going to get a 4 wood. Okay, huh? All right, done. Okay, now I'm going to increase the resistance of rheostat. Okay, I'm going to use a green color. Let's say I'm going to increase it from 2 ohm to, let's say, 5 ohm. Okay, why I choose 5? Okay, maybe you know why I choose 5, so that I will have better answer. Okay, all right, so I'm going to recalculate my total resistance. There's no place there. Probably I will erase the one at the bottom, okay, so that I have extra space. All right, okay, huh? So I'm going to calculate another set. All right, starting with resistance. Since I changed 1 ohm to 2 ohm to 5 ohm, so I'm going to have total resistance. All right, this will be a 5. All right, I will get a total 6 ohm. Do you see 6 there? I'm going to erase and write again. 1 ohm plus 5 ohm. All right, so the new current is going to be still Bu over R. All right, it's going to be still a 6 over 6. Okay, yeah, it's 1 ampere. But when I calculate my Bu2, what do I get? It's going to be still IR. All right, even though the current is smaller, right? But the resistance, remember, I changed to 5. And now I'm going to get a 5 volt. Do you notice that? Do you notice that? All right, do you notice that my Bu2, all right, actually increase from 4 ohm to 5 ohm. Okay, I show in the box, huh? All right, okay, you notice that? All right, so originally when Bu2 is 4, then Bu1 must be 1 volt, so that total up, sorry, not 1, 2 volt, so that total become a 6 volt. Boleh? All right, Bu1, 2 volt and 4 volt become 6 volt. Okay, but when I increase the resistance of rheostat and I'm getting my Bu2 as a 5, all right, what happened to my Bu1? So my Bu1 must be 1 volt. Faham? So that Bu1 plus Bu2 must give me a 5 volt. Sorry, Bu1 plus Bu2 must give me a 6 volt. 1 plus 5 give me a 6. Boleh? All right, huh? 1 plus 5 will give me a 6. All right, so understood. Bu2 increases. All right, okay, Bu2 increases and Bu1 decreases. Okay, people get it? People? All right, get it or not? If you get it, can I go to the next one? All right, if you find that it's a bit hard, so you put number. Clear? I repeat one more time. I repeat. If you think you need to have a little bit longer time. All right, now initially I put 1 ohm and I put 2 ohm. Okay, so I calculate the total resistance. All right, 1 plus 2, I will get a 3. Okay, huh? Then I will find the current. Okay, current understood, 6 over 3, I get a 2 ampere. All right, then the next step, I will find Bu2. So Bu2 is IR. All right, my I is 2. All right, and my R of the rheostat is also 2. That's why I get a 4. Betul? That's why I get a 4. All right, huh? Okay, so understood. Okay, if Bu2 is 4, then Bu1 is going to be 2. Because we know Bu1 plus Bu2 becomes 6 volt. Betul? All right, and now I am increasing the the resistance of the rheostat. This is a rheostat. Okay, do you see there's an arrow there? All right, there's a rheostat. I increase from 2 ohm to a 5 ohm. Faham? So I recalculate. Okay, so when I recalculate, you notice that 1 plus 5. Okay, I highlight in yellow. All right, to give me 6 ohm. All right, 6 ohm. So my current will be 6 over 6. I get a 1. So again, I'm going to calculate Bu2. All right, Bu2 equivalent to IR with a 1 times 5, because the resistance now of the rheostat is 5. Then I get a 5. So you notice my BU2 actually increased. Clear? My BU2 increased from 4, right? Okay, from 4 to 5 wood. Okay, but my BU1 actually dropped or decreases, drop from 2 to 1. But in exam, you cannot be doing this, very time-consuming process. All right. Okay. So the only way is you are going to do more work or do more exercises. Okay. Let's move. All right. This is question that need you to use the formula of internal resistance. All right. Basically, the formula that I am talking about is this type of formula. Clear? So identify. Right. The bigger value is always electromotive. Okay. So you're gonna put it here. The smaller BU is always the value of the BU. All right. And the current is given as 0.2. These are very popular, huh? All right, popular. Okay, and this week I'm going to go to a graph concerning this. So I substitute in, all right, I substitute in and you'll be able to see negative 0.2R to the left, become positive, all right, and 1.2 move to the right, become negative 1.2, 1.5 minus 1.2 becomes 0.3 and there you go, all right. 0.3 over 0.2 is going to be 3 over 2. That will give you 1.5, all right, okay. Then we're going to look at the next one. All right, you have electromotive. All right, you have the small r, you have the big R. Chances is you are going to use the second set of the formula. All right, because you got big R, you got small r. No? This is where you put the big R, this is where you put the small r. It's electromotive here, they ask you to find current. Okay, looking at this is easy, but if your brain does not have this formula, all right, then you will probably don't even know that you are going to do simple work. Put the 3, all right, into the E, all right, and put the 0.5 into the small r, all right, and put the 1.5 into the big R, and only unknown is going to be current. That's all right. So 1.5 plus 0.5 become a 2, all right, okay. 2i equals to 3, so I equals to 1.5. That's all right. Shall we move to the next one? Okay, huh? This is a set that I have sent to you earlier on, but many of you didn't do, but it doesn't matter, all right? Okay, those who want to do, then you will know that you'll be better than other people who never do, okay? Okay, if you read electromotive, okay, it's the value of the voltmeter when the circuit, all right, is open. Do you notice the word here, switch is open? Okay, do you notice that? That means this is the value and the switch is open. So understood, when you on it, what is the reading of the voltmeter when the switch is closed? Closed means you on it, right? Switch means closed, meaning you on it. You know that this value of the voltmeter, right? The value of the voltmeter become the BU, which is normally we will write using this formula, BU equivalent to electromotive minus IR. And we know electromotive is a 6. We start with a 6 just now. All right. This value is going to be electromotive. All right. So we minus something. We minus something. Even though the number is very small, let's say it's going to be a 1 times 0.1, you still minus a number. You still minus a small number minus 0.1, you still get a number which is going to be smaller than 6 wood. That's why your answer will be a C. All right. Okay, let's move. You shouldn't complain what I do is very hard. Power equals to VI. All right, nothing to explain, just masukkan. Right, 2000 masuk dalam. These are basic question that I've given to you to do, but I think quite a big number of you didn't do, but it's okay. All right, that's why, okay, hang on. All right, okay, that's why I would rather do it here, right, instead of keep on waiting for people who are, okay, who didn't do, or you are not motivated to do. All right, so you're going to press your calculator 200 over a 24, all right, or 100 over a 12, all right, they will give you a 8 point something. That is the answer there. All right, let's move. Calculate the quantity of charge. Okay, remember we start with the formula I equals to Q over T. The one Q, right, is going to be IT. So I'm doing all the basic things now actually. all right? Because I still see some people are not good, okay? They say 1 hour, right? Then change it to second, all right? 1 hour change to 60 minutes, and then 60 minutes change to 60 seconds. If you are good, these two number, you're going to get a 3600 times 3. This is 3,000 times 3. It will be near to 10,000 plus. That's why your answer is donkey. All right. Okay, I'm going to go on to the next one. Then, what is which of the appliance consume least, the lowest energy? Then you use the formula, right? They give you power, they give you time. So understood, all right? The energy will be equivalent to PT, all right? If you wonder where it comes from the basic formula you study in Form 4, power equivalent to energy over time. So cross multiply will be energy equals to PT. So what you do is you multiply this and this, all right? Then the first number you get 1600, all right? 1,600, all right? Okay, the third one, 1,000 times 2, you know it's a 2,000. Wow, bigger some more, right? This time this, if you're good in maths, you know it's a 600. Perhaps that is the smallest number, all right? You don't have to press your calculator, all right? You know that it's going to be, let's say, 85. You take 85 times 10, it's going to be 800 already, all right? So it's definitely 85 times 10 is going to be, all right, more than 850. So you know the smallest number will be 600, okay? Right? The smallest number will be actually 600. Even if you have no calculator, right, you can roughly get the value, all right? Okay, if you're not good in maths, then you have to keep on pressing your calculator. All right, okay, we're going to go to the second set. I give you two set objective, all right, which is correct. Understood, the arrow must be from positive charge to negative charge. So take a good look. Positive to negative, understood, it will be a donkey, agree? Sorry, C, okay, C, yeah, positive. This is terbalik, okay, positive to negative, okay, this is all terbalik. Clear? Terbalik. It must be positive to negative, all right, and this also terbalik. So only C is correct. Clear, huh? All right. B, understood, positive to negative, there will be a line joining them. Clear? Right? This is missing. Clear? All right. And then positive and positive for A, this one should not join together. Clear? All right. Let's take a good look. Okay. What is the current? So understood. Okay. With power and boo, understood, you are going to use power equivalent to VI. That's all. Clear? All right. And the power, you're going to change it to watt. All right, they want to find for current, understood, your subject become power, your boo will be at the bottom. All right, 0.5 meaning 500, okay, over 240. So basically, if you're good in math, it's like 500 over 250, which is going to be 2 point something. Betul? All right, so no need calculator if you're good in maths. All right, next one. All right, okay, this is a little bit demanding. If another identical wire, all right, is connected, okay, if you look at the first paragraph, it says that same material, same thickness, all right, okay, but different in length. You notice that wire 2, understood, wire 2 is longer than wire 1. Look at the drawing, all right, okay, look at the drawing. This is wire 2 is slightly longer. Right, it's slightly longer. Wire 1 is slightly shorter. Betul? Right, it's slightly shorter. So understood. Okay, they ask you if one more identical wire, all right, is connected in series with wire 2. Meaning what? Meaning understood. I'm going to connect another wire here. Another here. Right? Another here. No, I cannot draw. If I draw, then no more space. What is the changes? Understood. All right, understood. If I connect one there, that means the resistance become higher for this circuit. Okay, higher. Okay, all right, huh? Let me show you the relationship, huh? All right, okay. So when the R that I put is higher, then the current that flow, okay, the current become lower. Current become lower, understood. Your reading for your A2 is going to be directly lower because the current flow through A2. Faham? All right? Current flow through A2. All right? And what about your BU1 and BU2? BU1 and BU2, we don't disturb. All right, let's say I'm going to have 2 dry cell here with 3 wood. No matter what I change, all right, the wood meter reading at the top, which is Bu1, and the wood meter reading at the bottom, which is Bu2, will remain the same because it's parallel. All right, no matter what you do, both are going to be 3 wood. This is going to be 3 wood. All right, and this is also going to be 3 wood, no matter what you do to the resistance. Clear? That is what you learn in syllabus. Faham? All right, so your Bu1, Bu2 must be the same. It will be either this and this and this and this. Okay, all right, and you know that your ammeter reading A2 is lower. This is lower. So understood. Chances is your answer will be a C. Clear? All right, I think I made myself pretty clear. All right, before I move, I'm going to repeat one more time. Because of the power supply of the Bu is 3 wood and the arrangement of the circuit is parallel, right? So the reading of Bu1 is also 3 wood, Bu2 also 3 wood. And because we add one more resistance here, all right, it will make the resistance go higher here. So when resistance go higher, your current become lower. Resistance and current always opposite. This will make your reading of your A2 become lower. All right. So an ammeter reading is lower, okay, but you don't disturb the circuit at the top here. All right. That means your current here is the same. Current here is the same, which I label as I1. Therefore, your reading of A1 will still be the same. Clear? That's why the answer is a C. All right, let's move. All right, these are a little bit important, huh? All right. Okay, first step, they ask you to calculate the energy release. So you know the formula. Okay, when they ask you question like this, the best formula is you're going to use the second one. All right, I always tell people to use I squared RT. Okay, got reason, huh? Right, got reason. You don't have to be bothered to find the book. Clear? All right, because sure you can find the current. They are talking about the bulb, so that's why I'm going to talk about the bulb now, which is here. All right, so first step, as usual. All right, first step will be total resistance. All right, do you notice total resistance? It will be a 3 ohm plus 2 ohm. Betul? All right, 3 plus 2 understood will give you a 5. What is the next step? Understood will be current. Now we stop here. We don't need Bu. All right, Bu over R. So you can see it's going to be a 10 volt at the top over 5. Then it's going to be a 2 ampere. Because we got the current here. Okay, just hantam into this formula here. All right, with a current 2 square and the resistance. Resistance of the bulb. We talk about the bulb, right? It's going to be a 3. All right, and the time they are giving us as 1 second, betul? And then you will hantam 1 here. So you're going to have 2 square become a 4 times 3. So understood in unit, okay, not watt, sorry. Energy, okay, it should be in energy. All right, energy. Clear? Doesn't matter, all right? Okay, but they put the time here, then it's okay if they were to give you in unit watt actually. All right, okay, you take away the time, then you'll be in unit watt. Okay, next one. Okay, which one of these consume the most electrical energy? Energy, again, all right, will be PT. Faham? Then you look at the power, and look at the time. Time is the same for everyone, is 5 minutes. So this one is constant. Then understood lah. Be smart lah. Look at the power. If the power higher, then energy consumed will be higher. Faham? Right? That's why people who buy very high power electrical item, then your energy consumed become higher. It's like a more powerful aircon. All right, the word is power. Ma? The more powerful aircon, the higher the power. All right, let's compare the power. All right, okay, video player 25 watt is the lowest among all. Then slowly go up, the table fan 350 watt. All right, television 450, this is 1005. So understood, the answer will be none other than the water heater or the kettle. All right, next one. Okay, this one will be using the formula of, okay, this kind of formula. Okay, all right, we will be using this kind of formula. All right, okay, voltmeter reading when the circuit is voltmeter reading, okay, is going to be 6 when it is switches off. That means this is your electromotive. Clear? All right, your electromotive will be a 6. Okay, when the switch is turned on, the voltmeter reading become 5.6. That means, oh sorry, That means this is going to become your boo, right? There are two value. One bigger, one smaller. All right, one bigger, one smaller. Understood. The smaller one will become the boo, and the bigger one become electromotive minus I. Sure, they give it an I. All right, 0.5, and then you calculate the small r. Easy job. All right. Okay, easy job. You're going to bring the negative 0.5 r to the left. All right, and the 6 minus 5.6 to the right. All right, then your answer is going to be 0.4 over 0.5 is going to be a 0.8 ohm. That's all. All right, I want you to get familiarized with this type of questions. This is easy. All right, remember, 4 ohm become a 2. All right, become a 2. All right, so it's going to be a 2 plus 3, then understood, total become a 5 ohm. All right, then this is the first step. Second step to find current. All right, okay, some of you will probably be telling me the question is too easy. All right, but some people are still scared. They're still scared to accept the challenge to do the work, even though it's easy. All right, okay, they're scared to take the challenge to do the work, and they end up not doing it. All right, okay, they end up not doing it, and this is what happened. All right, can I move? Can I move? Okay, I'm going to do another 2 to 3 more sets. Okay, maybe I give another set this Sunday. All right, but okay, it's a bit saddening when I have extra class like this, extra lesson. All right, out of 100 over students, I have only 23 students participating. All right, so what do you think? Should I be wasting my time on Sunday? You think about what I'm saying, okay? All right, I would expect, if not 100, okay, at least we have 50 people. All right, okay, but we only have barely 20 over people joining. Okay, doesn't matter. All right, so when we do extra work, okay, many students nowadays in this era, okay, they are less appreciative. Okay, all right, that's what I observe, and what most of my tutors also observe. Okay, this is what most of my tutors always observe. All right, that's why they are quite unwilling to give extra lesson to students. Public holiday, they will tell you bye bye. All right, okay, extra holiday, they will tell you bye bye. All right, okay, they want resistor. This is the resistor, so I'm going to put a big R there, not internal. But you still need to go through all the step 1, step 2 to find current. Step 1, total resistance, understood. All right, it will be the big R plus small r. All right, big R will be a 10 here, and the small r will be a 1 here. All right, so you need to add up. Betul? You don't add up, then you are wrong. Then the second one, current is going to be boo over R. All right, because boo is going to be a 6 over R is going to be 11. It's a lousy number, but you still okay. You put a lousy number there, 6 over 11, and you're going to put a square there. Then you're going to multiply the R. The R will be this R, all right, which is going to be a 10. All right, so your value is, you press your calculator, you should be getting your answer. All right, okay. Okay, people who are doing it, tell me the answer. It will be near to a 3, isn't it right? Okay, is that correct? Okay, it will be near to a 3. Okay, Chris Cody, correct? Okay. So anyway, or you can use other method to do. All right, but you see, you still get the same current. All right, You see, you still get the same current. Anyway, I'm going to move my pencil marking so that you can observe there is another way to do the work. Okay, all right. It doesn't matter what way. Do you notice that this is another formula you can use? Okay, electromotive I big R plus small r. Big R, do you remember, is a 10. This is your big R. This is your big R, remember? All right. Okay, small r. All right, small r, understood. This is your small r. It's a 1. So you get 11. It's similar to what I do here. All right. Okay, so your current here is similar to this number. Faham? That's why even though you do step 1 and step 2 like this, it's the same like using this particular formula. But some of you may not be aware of that. All right, but we don't stop there because they want power. So continuation, power equals to I squared R. All right, like what I show you lah, huh? Right, so the power, then you put in a 6 over 11 square, right? Okay, 0.55 square times it 10, then you get your answer 2.9 something, very near to 3 watt. All right, therefore your answer is none other than, you may press a calculator. All right, you may press a calculator too. Okay, I cannot be wasting time. I need to rush to cover more. All right, which graph show correct relationship between potential difference and current for non-ohmic. Ohmic, you know, is a graph which is direct proportional. Remember, you study ohmic. Ohmic is always whenever boo over I, there will be a straight line that go to origin. So understood. P is ohmic. Conductor S also ohmic. The one which is not ohmic, understood. All right, is Q because they ask for non-ohmic. Faham? All right, huh? Non-ohmic. Is it okay? All right. And then we're going to go to the next one. All right. Oh, this is similar to the question just now. How come you repeat here? Huh? You'll be less than 6. Okay, this is a repetition. All right. Repetition. Okay. We're going to go to subjective. Good. All right. We're going to go to subjective. All right. Okay. Let's take a good look. And that means we already passed half an hour. What is the meaning of ohmic law? Okay. Conductor, they obey Ohm's law. Ohmic law. Okay. Ohmic law, we call it. Ohmic law. Clear? I hope I will cover. There are two structure. All right. I hope I can cover the two structure here. Then followed by state the relationship understood direct proportional. Next one, calculate resistance. Then you calculate gradient. No? Gradient meaning you're going to look at the triangle. Masa ingat? All right. You're going to get a height which is going to be a 4 over the base. Be careful. This is 0.75. Calculate. All right. 0.75. All right. So you know that to find resistance, you find gradient. Betul tak? To find resistance, you actually find gradient. Okay. To find resistance, you actually find gradient. Right. And you are going to have right 4 over 0.75. All right. Okay. If you are not aware of this, please make sure you are aware. All right. Let's move. Okay. What is the meaning of power? You must know power is equivalent to energy over time. So in other words, we get a 3,000 watt got meaning. That means it consumes 3,000 joule of energy in 1 second. All right, because the unit for energy will be joule. The unit for time will be second. That means it consumes 3,000 joule in 1 second. You need to mention that. All right. Power is, you can answer like this. Power is the rate of energy transfer. All right. Rate of energy transfer. All right. Or the, okay. This is the one, rate of energy transfer. This is the one. This is the one. Okay. This is the one. Rate of energy transfer. Power is the rate of energy transfer. Transfer from what to what? Depends. This is a kettle. So you will transfer from electrical energy, all right? You will transfer to heat energy, all right? Because the function of kettle is to boil water, all right? So how fast it transfer the energy? Faham? Clear? But I need to explain this to you to make sure that you know what is the meaning of 3,000 watt. That means it transfers 3,000 joule of energy in 1 second, all right? Okay, so understood. This is E, this is P. So you know that power equals to, all right, that they want you to find the relationship, all right? You know that power equals to energy over T, right? Or you cross multiply, all right? Energy equals to PT, all right? Betul? Okay. So it's either one, you can show the first one, or you can show the second one. They are actually the same. All right, you just cross multiply. Next one. Okay, so power goes to VI, easy job. All right, they show us to find current one. Sure. All right, power goes to, okay, sorry, power goes to VI. Sorry, Okay, power goes to VI, so they want to find current, then power over book. Betul? Alright, power equivalent to VI. So understood, it will be, put in the value, right? 3000 at the top, all right? 240 at the bottom, you get the answer. Resistance, all right? Then there are two ways of getting resistance. You can use the normal way, all right? This is the normal way, resistance equivalent to Bu over I, because you know your I already, right? Bu is 240 over 12.5. If you don't want to use this, you can use this formula. Power equivalent to Bu squared over R. Pun boleh, right? So you want to find the R, right? R and P change place. Huh? Don't worry, the answer will be the same. R equivalent to Bu squared over power. You calculate, your answer will be the same. Clear? All right? Don't believe, you can try. You're going to put a 240, you're going to put at the top over power, but be careful with the square. Huh? All right? Okay? These two answers will be the same. Clear? All right? It will be the same. Don't worry, it should be the same one. Boleh? Okay? Right? So this set is actually meant to make you familiarize. Okay? Calculate amount of energy. So energy goes to PT. That's all. All right? Okay? If you want to use normal formula in joule, then you just maintain the unit watt. All right? Okay? You can maintain the unit watt. All right? Okay? So, okay, watt, this is watt. Okay? This is going to be second. All right? Because you times 60. 10 minutes times 60. So your answer will be in unit joule. Clear? Right? Your answer will be in unit joule. You may also answer in kilowatt hour. Then your number becomes smaller. Right? Your number becomes smaller because energy equivalent to PT. All right? Then kilowatt hour. What did I say? Kilowatt hour. Kilowatt meaning you change the 3000 watt to kilowatt. It's only 3. Faham? And then hour. 10 minutes change to hour. 10 over 60. All right? Okay? And unit is going to be in hour. So I'm going to cancel off. You're going to see very small number. 3 over 6, 0.5. And what unit? It will be kilowatt here because you already changed 3000 watt to 3 watt. And 10 minutes change to hour. That's why your final answer is kilowatt hour. So this is also your correct answer. All right? It's not wrong. Okay? Instead of this, they are the same. Only different unit. Now they ask here. They ask in the next question. You will see my calculation here for the second one. Faham? Clear? All right? They ask you here. Okay? That's why your answer is. Boleh? Move on. All right. This is the next question. All right. So V and I with electromotive 9 volt. All right. Let's take a good look. What is electromotive? Then you must use the word energy supply. All right. To move one unit of Coulomb charge in an open circuit. All right. Energy supply. It must be energy supply. You will use what formula to explain? All right. You will use this. All right. Energy. All right. Over quantity of charge. Understand? All right. I repeat. Okay. Electromotive. So we will assume this as electromotive. Right? We will assume this as electromotive. All right. It's meant by amount of energy supply to move one unit of Coulomb charge in an open circuit. You must have the word open circuit. That means you have not on it yet. All right. So how does I vary with V? You notice that when V go down, then the I go up. Do you notice that? I go up. Faham? All right. That means when your I go up, V come down. Atau terbalik. I go down, V will go up. All right. I repeat. All right. Look at the table. All right. Your answer based on table. All right. Okay. Look at the table. Look at the first column. This column. All right. From 9 volt become 8.1. Okay. Your V go down, then your current from 0 to become 0.4. All right. Then you know that when your V go down, all right. When your V go down, I go up. This one. All right. And your V go up, your I go down. Faham? All right. So you give either one. All right. I decreases as V increases, or I increases when V decreases. Up to you. Clear? All right, huh? Then represent what in terms of energy. You still use the same formula. But you're going to have you're going to have a little bit of changes, right? Okay, you have a little bit of changes. Energy used to move also 1 unit of quantity charge from one point to another point in a closed circuit. You must have the word closed circuit. All right. Okay, energy required to move 1 unit of coulomb charge, all right, to an external resistance in a closed circuit. Faham? That means you on it, right? You on it. Okay, that is called Bu. Right, that's called Bu. So I repeat, Bu is the energy used to move 1 unit of coulomb charge, all right, from one point to another point, or use the word, right, to move it to an external resistor, big R, in a closed circuit. All right. So deduce a concept. Okay, deduce a concept. All right. Okay, just now you already learned. Okay, when current go up, the V go down. Why the V will go down? Because energy is used. All right, energy is transferred. Okay, when current go up, energy is transferred to the external resistor. All right, decreases. Clear? All right, and why it happened? Why it happened? All right. Okay, when you on the switch, that means the current will flow, current increase. Some of the energy is used, all right, is transferred, right, to the external resistor, the big R. All right, some of the energy is used to overcome the internal resistance. Remember, that's why we have this formula. That's why we have this formula that you learn. Faham? Okay, huh? You don't understand? Let me explain to you, huh? All right, this formula work like this. All right, work like this. Okay, faham? Tengok, huh? Tengok, huh? When you off your switch, meaning circuit is incomplete. Okay, circuit is open. What happened? Your current becomes zero, no? Your current becomes zero. So current becomes zero, meaning what? Your reading of a voltmeter will become electromotive minus 0 times R. So it's going to be electromotive minus 0. That's why your voltmeter reading is electromotive when it is off. Understand? All right, and this value is normally higher. Okay, huh? All right. But when you on it, that means got number. So my formula still the same, but got number meaning I got current already. All right. Okay. The current, let's say, is going to be very small. Okay. 1 ampere, and the small r is also very small. Also 1. So 1 times 1 is still 1. So you will get a smaller reading because of electromotive minus 1. Faham? All right. So electromotive, we don't care what number. All right. If we start with electromotive as a value, let's say as a value 10 volt. All right, 10 volt. Then when you on it, your value 10 volt here, you still have to minus. You still have to minus 1. All right. You still have to minus 1. So your value will become, all right, your value, well, I accidentally press another. Your value will become 10 minus 1. Clear? All right. That means your voltmeter reading become less. Okay, huh? All right. So I need to come back. Okay. Accidentally press. Okay. I'm going to repeat. Okay. What I mentioned just now. All right. Part of the energy is used to overcome internal resistance. Okay. So the concept used is actually the concept of internal resistance. All right. The physics concept applied, okay, is internal resistance, which is the resistance inside the dry cell or the battery. Clear? On the light. Okay, we are going to complete this one. All right. Are the bulb connected in series or parallel? Understood. It's parallel, right? Okay, because you got many ways for it to flow. Clear? Right. The current, let's say the current, okay, from the live wire here. All right. Okay, it will flow, okay, in this way to come back. It flow this way to come back, or it can flow this way also to come back, or it can also flow, okay, it can also flow this way to come back. Faham? Clear? So there are many ways that is parallel. What are the advantages? These are from 3 questions. All right. Remember parallel is, I'm gonna draw parallel circuit, huh? It's like this. You got 3 bulb, okay? The first bulb, all right? Then I'm gonna draw the second bulb, and I'm gonna draw the third bulb. So what do you learn in parallel? All right? Let's say I give you a 3 volt here, then every bulb will have 3 volt, understand that? So you put a voltmeter across the bulb, meaning that you're going to put a voltmeter here, is also going to be 3 volt. All right, huh? All right. And not only the bulb is the same, current also the same. Let's say the current that flow through the first bulb is 1 ampere. All right. The current that flow through the second bulb also 1 ampere because they are the same bulb. Same bulb meaning the same resistance. Clear? So not only the bulb across each bulb is the same, they give you the same brightness. Current that flow through every bulb also the same value. So it will ensure that the bulb all light up with the same brightness. Not only that, you can have different switches. You can install one switch here. All right, you can install one switch here, and you can install one switch here. You can install one switch here. You have separate switches to control the first bulb. Let's say I label bulb A. To control the second bulb, let's say I label bulb B. To control the third bulb, let's say I label bulb C. This is from 3 questions. Right? Brightness of each bulb is the same because current that flow through each bulb is the same. Potential difference across each bulb also similar. All right? And it doesn't depend on how many bulbs. All right? Even if you were to connect one more bulb here is still going to be 3 volt. All right? And one more bulb here. All right? The bulb is also 3 volt. We don't care how many. And the last one is like I mentioned, every bulb can be controlled individually. Each bulb can be controlled individually, all right? Okay, and all the bulbs can still light up even though one of the bulb, okay, is burnt. Clear? And this one is from 3, you know, right? From 3. So I don't have to spend too much time on this. Tingkatan 3. Let's move. All right. So this is a question to talk about how do we make sure the room, okay, which is initially dim, not only that, also warm, all right? Why? Because we use filament bulb, and you know filament bulb nowadays nobody use, all right? Yeah, we will start to use fluorescent. Even fluorescent now is not good, right? People are talking about using LED now. LED is giving you maximum amount of light energy, but minimum heat energy, all right? Even though got filament bulb, air conditioning, standing fan, all right, they are switched on. So suggest modification, modify, so that the room become bright. We don't want it to become dim. We want it to be bright. Okay, we don't want it dim. We want it bright. Okay, don't want it to be warm. We want it to be cooling. All right. Okay, and you want to have this efficient use of energy. All right. So you're going to come up with suggestion, all right, the type of light or bulb, position of aircon, position of the standing fan, all right, the use of curtain and the type of flooring. Clear? So you need to give that kind of modification. This is suggested one. That's why I mentioned we don't use filament bulb. Okay, we only use in the toilet. Even if we use very small power, 5 watt will do. 5. All right, the very small bulb that normally similar to the one people use in the lantern, all right? Okay, 5 watt or 10 watt. So we use LED, all right? LED understood, it will convert to more light energy, become brighter, and it will consume less, all right? It will produce less heat energy, all right? And we put the air conditioning, if it's possible, in the middle, right? That's why normally people put the ceiling, the ceiling type of the aircon right in the middle. You go to the bank, they all put the ceiling type right in the middle, all right, so that it will give you better, okay, cold air ventilation, all right, to ensure the whole room can be cooled down faster. Ceiling fan, why? Because ceiling fan is normally also placed right in the middle, clear? All right, better distribution of cold air, all right, and this will improve, okay, air circulation or air ventilation. Understood? If possible, use a curtain or use blind, because you're going to block, all right, or reduce the amount of heat energy from the sun. Betul? This is a modification, right? Insulate the floor with carpet. You know, carpet is a good insulator, right? All right, good insulator meaning that it will slow down conduction of heat. All right, all right, from the floor to the room. Clear? Okay. And this is going to be the, okay, I think we will stop here. All right. People want me to continue, people? You want me to continue? Do you want me to continue? All right. Let's take a good look. You want me to continue? This is the last one, I think. All right. Filament in a bulb is made of resistance wire. All right. Meaning normally is high resistance. Reason to produce heat lah. All right. To produce heat. Clear? All right. Heated up, okay, to high temperature, and it will start to glow. Okay, thus producing heat. All right. Right equation for the power produced. Okay, in terms of, all right, understood. They want power. So you know the formula, power equivalent to, they want the formula between Bu and R. Understood the third formula, right? Bu squared over R. Betul? You cannot write, you lose 1 mark. Okay, itu sahaja. Write another equation, all right, in terms of what? Current, all right, and R. Understood? That will be the second one. Also include power. Remember the formula? Power equals to the second formula. All right, we want current. Do you see the V1 current? V1 R. Okay, we did just now. Okay, I squared R. Betul? All right. Okay, easy job. All right, next one. Okay, based on the two equation and other relevant information, explain whether high resistance filament or low resistance filament is suitable. All right. Okay, high or low is suitable. Okay, high or low is suitable for a bulb of high power. We want high power. We want high power. All right, we want high power. All right, then the formula is going to be this. Bu squared over R. We want high power, meaning take a good look. This one must be high. P must be high. P high, then R must be low. R must be low to allow bigger current to flow. Understand that? All right. Okay. R must be low to allow bigger current to flow. All right. So that it will become hotter and brighter. All right. Okay. I repeat, Okay. I repeat. Okay. High power. Resistance must be low. Resistance low, then current high. Current high, then understood the bulb will become brighter. All right. Okay. A bulb is usually rated according to operation voltage. All right. Which is stick at 240. Okay. Look at the formula here. Power equals to V squared over R. All right. The higher the power, the lower the resistance. Clear? All right. So the resistance must be low. Okay. Resistance must be low. All right, resistance low, understood. It will allow bigger current to flow through the bulb. Okay, to allow bigger current or higher current to flow through the bulb to produce brighter effect. Okay, to produce brighter effect. Boleh? Okay, it's following what I've given to you. All right, I repeat. Okay, if you are not able to get it, I'm going to repeat one more time. They want high power. All right, they want high power. So I'm going to write this high power here, and you observe resistance become low, right? The resistance become low, right? So I'm going to write down here, when resistance become low, understood, it will allow bigger current to flow through, right? Resistance become low, then it will allow bigger current to flow through so that the bulb become brighter. Clear? All right. And it's talking about filament bulb. All right, it uses a very thin wire, thin conducting wire in a coil. When current passes through it, heat produced raises the temperature of the filament to more than 3,000 degrees Celsius. Then it will glow and produce light. Okay, you see what they're asking for. If the filament bulb connected to 240 wood, and the power is 60 watt. Calculate the resistance. Then the same formula. Power equivalent to Bu squared over R. All right, you just substitute in, your answer will be there for your R. Change the place, right, between P and R. So that your P, okay, go down, and your R become the subject. So Bu squared over P. All right, be careful with the square. You forget the square, then your answer will definitely be wrong. All right, huh? So you get the answer there, 960. So some of you will say, probably say what we do is easy. Okay, now this is the last one. All right, this is the last one. All right, you show a table. Table gives various characteristics of a few types of material. Using information, discuss the relevance of each of the character in deciding whether particular material is suitable. We want to see suitable for what? Right, the purpose of making a bulb filament. This type of bulb. Okay, this type of bulb. They are talking about this type of bulb. Okay, all right, huh? Choose the most suitable material. Okay, understood. Melting point. We want melting point to be high, all right? Then we look at the high one. This is high. This is high. All right. Then okay, the length of the wire that has resistance. Okay, we know this bulb here got limited space. We cannot have long wire. So if possible, we will locate the short one. All right. Okay, the short one. This is short. All right. This is short. This is also short. This is also short. All right. And this also can be considered short. Clear? Then the third one, we are asking for what? Can the material be drawn into thin wire? Sure, ma. If not, how to make filament? All right. If not, then how are you going to make the very thin filament? Betul tak? Sure, yes, ma. Yes, 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 yes. So we know. All right. The last one cannot be used. Strength of material. Sure, we want it to be strong, ma. All right. Okay. Strong, strong, strong. This one probably also. Okay. So understood. The one with all the marking, and I think will be tungsten. And understood lah, tungsten is the one, or nichrome used, all right, okay, in the, how should I say, right, in the, as the filament in the bulb, okay. We also can have nichrome, but nichrome not as good as tungsten, because tungsten have a higher melting point. Betul tak? We check the answer, all right, we check the answer, clear? All right, okay, let's take a good look. Melting point, understood, it must be high, all right, high so that it will okay, withstand a high temperature, it will still glow and produce bright effect. Length, okay, we know that it's limited space, it must be short, all right, you coil into small volume to fit into the bulb. Understood, ability to make into wire should be high lah. All right, it must be able to make into thin wire. Otherwise, we cannot make filament. All right, then strength, understood lah, it must be stronger so that, all right, okay, all right, since the wire will be thin, it can easily break. So we want it to be strong, right, to prevent the wire from breaking. Okay, so understood. Okay, remember we talked about tungsten. All right, we talked about tungsten. Okay, so tungsten will be the best choice. All right. Okay, then you repeat now. You repeat. It has got high melting point. All right. Repeat here. It has long wire. Okay. All right. Not long wire. Okay. We know we want it to be short. Okay. Then you mentioned the length of the wire must be short. It can be made. It can be made into wire. All right. And finally, all right, the material must be strong. And then you will be able to get all the marks. Clear? All right. And of course, I think we will stop there. All right, the last one is not very important. All right, okay, the last one is not very important. Okay, I will see you then. All the best to you. And those of you who have class tonight, we will start at 7:30 again. All right, okay, I will see you then. All the best to you. Okay, bye-bye.